Good morning, good afternoon, or good evening. No matter the time of day or where you're joining us from, we sure thank you for being here. I'm your host, Steve Henning, and this is the CVBNetwork Podcast, where we cover a variety of topics all related to the work truck, van, and trailer ecosystem. Today, we've got a really special guest and a great topic. We're going to talk a little bit about bringing smarter work trucks to the forefront before they ever hit the road. And I think what we're going to do is look at the critical step of pre-vehicle build specking, if you will, using software to model things like weight distribution, payload capacity, center of gravity, and even looking at regulation, all before a single piece of equipment is mounted on that chassis. And I think most of us in this space probably realize why we might be talking about this, but just to provide a little context, today's work trucks, high value, frequently very high dollar, and very highly customized. So weight, balance issues, those kind of things, if they're not caught early, those costs can really compound pretty quickly and become a problem. So if we look at, catching oversight during planning, really you would probably consider that more of an investment. At least that's how I would look at it, rather than discovering something after the fact, like, I don't know, an overloaded axle, maybe a payload problem after the truck is built. Well, usually I would think after the truck is built, probably can be pretty expensive, maybe lead to rework, delayed deliveries, safety liabilities, and probably worst of all, lost customer trust if it impacts a job that someone's working on. So getting that math right is just critically important. The good news is I'm not the expert in this, but we have an expert joining us today, Sorcha O'Grady, who is the Chief Sales Officer and co-founder at Truck Science. The Truck Science really helps, I think, commercial vehicle professionals design and spec vehicles with confidence before that production ever begins. But we're going to dive into that a bit more. But first and foremost, Sorcha, welcome and thanks for joining us today.
Thanks for having me, Steve. It's my pleasure.
Absolutely glad to have you here. And I'll start off with what might be the easiest question. Some people though think, gosh, this is the most difficult question because it's about yourself. Can you tell us a little about yourself? Maybe your background, how you found your way into this space that we all, I think, work in and love dearly.
Thanks, Steve. I actually started my career as a teacher, and from there went into software development. I had some management and account management roles through that work. I worked in Europe, Australia, the US, and Africa in my work as a software developer. And then finally, about 15 years ago, I joined the family business, family business of mechanical engineers and software engineers. And as you can imagine, all of those previous roles greatly contributed to my work in this space, from presenting info in a way that's easy to understand, to understanding the possibilities for software integration and what software can do. So I now find myself as the Chief Sales Officer at Truck Science and really enjoy the customer interaction and the constant quest to just improve the software and make it accessible to the users. That's pretty much me, I guess, in a nutshell. I'm 15 years in this role now.
Oh, fantastic. That sounds like a really kind of neat background, exposure across many continents around the world and working with a lot of customers. And I love the fact that you said looking for that continuous improvement. I think that's just essential today. No matter how good we think we have things, there's probably always ways to make it better. So maybe that's a good lead into my next question, which is anybody that's not familiar with Truck Science. I know I tried to give it a really brief definition, probably didn't do it justice. So maybe you could tell us, what is Truck Science and who typically uses the Truck Science platform?
Yeah, so in essence, the Truck Science software is software for building the best truck for the job. There is no best truck. There's just the one that's suitable for the job at hand. And that involves really choosing a suitable chassis and then laying out bodies and equipment in a way that's, we say, safe, legal, and efficient. So, it's the combination of the chassis, the body, the equipment, laid out in a way that's in compliance with both the OEM's limits for the chassis, states limits for, the weights on the individual axles, axle spacing, gross weight of the vehicle, all of that. And then that final piece is efficiency, and that is to maximize or optimize the payload within those constraints of what's allowed by the OEM and the road or surface that the vehicle will operate on, I guess. So needless to say, there are lots and lots of considerations, but those are kind of our three guiding lights. That's safety, being legal or compliant, and having an efficient truck at the end of the day.
I like the phrase you used. I've frequently heard the right truck for the job, but your phrase was the best truck for the job. I like that even a little better. And you talked about essentially those three pillars. Is one more important than the other, or are all three equally important?
Yeah, I guess it depends who you speak to. If you're speaking to somebody at your DOT, they will tell you that being legal or compliant is the most important. If you're speaking to somebody at your chassis dealership, and you need to make sure that your warranty stays valid, then they'll talk about complying with the axle limits. And probably where you're talking to the fleet or operator of the vehicle, they want efficiency is key for them. So we really hold them all equally important. And I guess that equal importance comes from the different stakeholders whose interest it is in to get the best vehicle for the job.
That makes a lot of sense. In the world of marketing, we frequently talk about your audience. In your world, you just said it, it's the stakeholders. So I think every stakeholder probably has a slightly different answer on what's most important. But from what you just said, I think it means they're all equally important to everyone. So they should all be equally considered. So let's talk about, let's say a customer is in the market for a work truck. Most of the time, they probably have some type of vision of what they think that truck will be or will look like, or what type of equipment and so forth. But then sometimes that vision maybe meets up with reality. Do you usually see a place where that vision and the reality start to, I guess, diverge a bit? Is there? It's not a tipping point necessarily. That's the best phrase I can come up with. But is there a point where those two things frequently tend to diverge?
Yeah. So truck science is used by chassis OEMs at a head office level and their dealerships. It's used by truck body and equipment manufacturers, upfitters, fleets, and then both the acquisition specialists and the operations of those fleets. And finally, by accident reconstruction specialists, and that's maybe an area we don't like to think about, but that is the reality. That's the worst case scenario, I suppose, down the line. And where we typically see, a customer's original vision and the reality separating, sometimes a customer's vision starts with what we've always done, or, the truck I'm replacing. And, as you know, the legislation changes over time. So do the specs of the trucks from the OEMs, even, just new model ranges. The weights will change, or the ratings may change over time. So, following a weight analysis study, they may see that they're leaving payload on the table. Maybe that they're overspeccing a truck, that the chassis does not need to be as I suppose, trying to think of the word here, but sometimes they're overspeccing the truck. They don't need the chassis that they think they need. And then in other cases, axles can obviously be overloaded, but still more complex, I guess, is the situation where the truck is completely compliant in the fully loaded state, but not in an empty state, and that kind of comes into the picture when, say, there's a heavy crane on the rear of the truck or a heavy plow on the front, or sometimes the truck is actually compliant in one state but not another. So we talk about the importance of analyzing what it's going to look like in the full state, empty state, or even in between the two.
Yeah, that makes a lot of sense. You talked a moment ago about, I guess, axles and gross vehicle weight and so forth. I have a question, but I think it's kind of two questions, so I'll ask them both if you'll indulge me. Is and I think I know the answer, but is there a difference between, yes, it fits, and yes, it will work and work well? And I think related to that is there a misconception? I believe you kind of touched on that a moment ago. Is there a misconception that if a truck is under that gross vehicle weight rating, then everything is fine? Do people look at it that way? I'm going to assume they might, but that's not always the case. Is that a fair statement?
Yes. So to answer your first question about the difference between something fitting and it being right, the difference is, of course, like night and day. The fact that the body or equipment fits on the frame rail doesn't mean that the truck is optimal. We need to take into consideration the individual axle limits, and those are both from the point of view of the OEM's ratings and the limits for the roads that the truck will be operated on, and they normally come down from the DOT. We also need to make sure that the truck can handle predictably. So if there needs to be sufficient weight on the front axle for safe braking, for instance. And then in city situations, the truck needs to be able to turn safely. So we've been kind of talking about weight distribution up to now, but obviously center of gravity is also crucial. In terms of the stability of the truck. And center of gravity is determined obviously by the center of gravity of the chassis, but then all of the individual body's components and then payload, whether that's water level payload or individual payload items. But every component is changing the center of gravity. The positions of those components are also affecting it. You asked about the misconception that, if the truck is under the GVWR. And again, your point is absolutely correct. GVWR is just the total overall ceiling for the gross weight of the truck. But you can easily be 2,000 pounds under the GVWR, but still severely overloaded on, say, the front or rear axle. Or you can exceed the local bridge formula spacing rules. So, there's so much at play here. The math itself is pretty simple. It's just the combination of the chassis and all of the components and their kind of relative positions. And then the need to compare that with both the OEM limits and the legislation that, if you're trying to do this on paper or on a spreadsheet, things just quickly get out of hand.
Yeah, I'll bet. And I was chuckling a little bit. You said the math is relatively simple. Well, maybe for you. I consider myself reasonably good at math, but I'm not sure that math is simple for me. But I can tell you this. It was over the weekend, actually. I was on the road with my wife in the car, and we were driving behind a work truck. And just visually, I looked at it and went, boy, that really looks like that thing is about to tip over. Because they had, I think it was some type of crane they had mounted on it, and it was off to the side. And my concern was, I don't want to be behind it as it starts changing lanes or turning, because it looked like the center of gravity was off. So I think your point is really spot on there.
Yeah, and I referred earlier to truck science being used in deposition, in the case of an accident, and that's obviously the worst case scenario. There are lots of other problems that can be caused by not doing weight analysis up front, but that's kind of the worst case last resort. Yeah. And unfortunately, there are vehicles that are not spec'd correctly on the road, but our goal is to just make sure there are less and less of those on the road by making software available that makes this simple, makes it easy to get the information together that you need in order to spec the truck, and just helping to generate awareness in the industry that the software is available and that this is a task that needs to be done.
Yeah. You talked about, I guess litigation or being used in a case in the courtroom. The goal is to not get to that point, obviously. So I think that's a good segue to a question I had, which is, what are some of the most common issues that you see that can be caught by employing truck science in the planning stage and therefore avoid those types of issues?
Yeah, so we've already referred to the overloaded axles, and you mentioned quite correctly that being under the GVWR is not always or is not enough. You need to be within the limits for each of the individual axles, and that's down to the warranty of the OEM is not going to stand by a warranty that where the individual axles have been overloaded. It also affects the braking of the vehicle. And I guess that's from the compliance side of things. From a fleet's point of view, inadequate payload capacity is a big issue. So, as you mentioned, these trucks are a big investment and they need to be operating in an efficient way. Obviously, if you can get more payload on less trucks, it means a lot for your bottom line. So, that's an issue that we want to avoid as well. That insufficient bridge formula spacing, so getting the wheelbase or the CA of the truck correct. This obviously when it comes to towing trailers, etc., that's becomes very important that you're complying with those bridge formula limits. We already touched on that whole idea of steering traction and inadequate front axle weight. So it's important that while we're not overloading any axles, we're also not underloading, for instance, the front axle. And then, we haven't really spoken yet about left-right distribution or four corner weights, but it's also important that the side-to-side weights of the truck are balanced. And in particular, in the case of heavy asymmetric equipment, so where there's a heavy crane on one side, it's important then that whereas a generator may fit on that same side of the truck, maybe it should be on the other side to help balance out that side-to-side distribution. The problems are many. Thankfully, most of them are easy to solve, with a little bit of forethought and a little bit of planning ahead.
You stole one of my questions, but that's okay. I was going to ask you if you had a real world example of a proposed build. Looked great, maybe on paper, but then you ran the numbers and it wasn't quite so great. And you talked about, hey, it's got a generator over here and maybe they're going to put something else and suddenly go, no, that's actually not a good idea. But any other, real world examples that immediately come to mind where you said, the customer thought this was a good probability or a good option, come to find out it wasn't?
Yeah, I do a lot of, live demos for people who are hoping to use truck science and, come across all kinds of nightmare scenarios. And they are typically, in general, we find in the industry, people are trying to do the right thing. Their intentions are good. And sometimes it's just down to, what you mentioned earlier, that somebody is speccing a truck with just the GVWR in mind, and then they feel that if they add up the weights of all of the components and they don't exceed the GVWR, then it's going to be good. But do generally find, the more outlying in terms of, the distance from the center of the vehicle. So snow plows and cranes, lift gates tend to be to cause more trouble maybe than people expect, because they have that kind of leverage effect where they not only put weight on the rear axle, but they take it off the front axle at the same time. And, we kind of, we like to encourage a balanced vehicle so that both the front and the rear axles are being used kind of in a more even way. So you're not even coming close to reaching the limit on one and being quite under on the other, that you try to use the overall capacity of the axles in a more equal way, which obviously cuts down on the wear and tear of the vehicle also.
Many of your clients, I think, come to you in the build stage where they're getting ready to spec out a truck with equipment and so forth. Do you have any that come to you after a truck's already been built out with a, hey, we're not sure, or can you validate that this has been done correctly? Maybe they're buying a used vehicle, could be all sorts of different scenarios, but does that happen with truck science, or is it only on the front end, if you will, for a proposed build?
In some cases, there has been a fine, and they're just trying to understand, how can they make this vehicle compliant to get it back on the road. And sometimes it is a matter of just moving equipment around. We spoke about that kind of lever effect, something that's maybe at the rear of the vehicle. If it's moved forward, the vehicle can become compliant, or even in the case of a body, sometimes moving a body a couple of inches either way affects the payload by a couple of tons. Like, it's quite alarming sometimes to see how, the rapid and massive effect of very small changes, really.
Mm-hmm.
So yeah, sometimes it's when the organization has received fines. And then you also mentioned the maybe a used truck. So it may be that the truck's usage is being changed completely. And sometimes this is from, we work with a lot of cities, and in some cases they have a very different duty cycle of a truck from summer to winter. So there may be a plow and a dump body or something in the winter, and then they completely kind of reimagine the truck for the summer. So yeah, in some cases, in an ideal world, truck science is employed before the chassis is ever bought, so that you're choosing the correct chassis or CA to begin with. But most certainly it is used to maybe modify what's already in existence, to tweak something or to reimagine it altogether.
And you mentioned compliance, so we'll touch on that real briefly here. I know we're going to kind of run out of time, but regulations obviously vary by state, by municipality, by city, county, etc. Is there any advice you might offer, or in the world of compliance, how does somebody manage that manually, especially, but how do they manage that overall?
Managing it manually is I can't even begin to imagine what that must be like. There, as there are lots of different states, lots of different roads within those states, lots of updates to those regulations for those roads, etc. So the way we manage it in truck science is we have a designated compliance guy, and they monitor all of the regulations for all of the states and indeed the provinces in Canada. And our regulations engine within the tool is being updated constantly. And so that just takes that headache away for users of truck science. And they know when they log into truck science, they can see on our blog what has been recently updated. And their calculations are automatically checked for compliance against up to 5 sets of regulations at once. So if you have a truck and sometimes, a truck is being built and there is no customer yet, and it's just, it's being built in advance, I guess, and it's being spec'd for maybe a number of neighboring states. So you can choose up to 5 of those at once, and then know that there's a very simple kind of a traffic light system within the tool. Green means go, and red means stop, or change something. And so you can get your 5 green ticks for the 5 different states, and then that vehicle is good to go on those roads.
That's great to know. I like the fact that you have a compliance guy on staff as well. I'm sure that's reassuring for any clients. Okay, so we're about out of time. I was thinking maybe we'd wrap up with just a couple of rapid fire. Just give me your real short answer off the top of your head if you're willing. We'll try that.
Yep.
You okay with that? Okay.
Go ahead. Yep.
Okay. What's the most common equipment-related surprise?
It's probably, as I mentioned, just, the layout of that equipment. Sometimes the equipment is perfectly capable of doing the jobs as a crane or a refrigeration unit or whatever, but if it's put in the wrong place on the chassis, it's going to put everything out of kilter. Great answer.
Okay. Which of these is the most dangerous assumption? It fits, or we've always done it this way?
That's a tricky one.
It's a tough one, I know.
I think we've always done it that way is probably more dangerous, because it can be harder to change the mind of the person who said that. But that's where the math comes in, and these black and white reports that just show it's, this is the single source of truth. Physics is telling you that's not going to work. So, I think it makes it easier maybe to challenge that opinion. It's sometimes easier to challenge it fits maybe.
Fair enough. Okay. What is the one piece of information every customer should bring to the table for their first planning conversation?
Yeah, I think question number one is, what is this truck required to do? Whether it's, vocational job site, what are the PTO requirements? What are the storage requirements? What are the equipment requirements? Or if we're talking about payload, what kind of payload do you need to carry? What is its density? How much dimensions, weight, center of gravity, etc. So question number one is, what do you need to do? Don't fall in love with the chassis before we figure it out. What is the best layout on the best chassis for you? But question number one, what's the job to be done? There's a good book about not buying a drill, but buying it's the hole you want, not the drill. So start with the hole. What size hole do you want? And we'll find a drill that's going to make it for you.
What's, in your experience, what's the mistake that's easiest to prevent but expensive to fix?
Yeah, I think choosing the wrong chassis to begin with. So, if you've chosen a chassis with a particular CA, to try to reverse that or go back on that big investment, as you mentioned, is probably the hardest thing. But if you start off by analyzing what needs to be done, what's the best combination of chassis, body, equipment to do that, and make all the mistakes in the software before you turn a single bolt, then you can't go far wrong.
Good advice. Well, it's been a very enlightening conversation. For me, at least, I think the big takeaway here is, to use your phrase, the best truck for the job starts with asking the right questions. Look at the chassis, the equipment, the payload, the weight distribution, regulations. The list, I think, is pretty long, and that's maybe why it's a good idea to talk to the folks at Truck Science first. But look at those things. Look at those things before the build begins. By doing so, you can probably save yourself, possibly money, time, certainly, frustration, maybe, a lawsuit, perhaps. I think the list there is pretty long too. But again, start out on the front end. As you said, with the drill, what kind of hole are you trying to make? And then you can determine what type of drill and drill bit you might need. So great conversation. I sure appreciated your time today. Thanks for educating us. And maybe we can connect again down the road and further our conversation. But Sorcha, thanks so much for enlightening us and educating our audience a little bit. We really appreciate it.
Thank you, Steve. It's been my pleasure.
And for those of you that are watching, please be sure to always, subscribe to CVB Network. And on this particular podcast, we will also include a link to Truck Science. So if you have more questions, I'm sure that Sorcha and her team are more than happy to talk to you about that and see if they can help out. Until next time, thanks so much.